do this. Okay, a store has been selling 200 compact disc players a week at $350 each. They did a market survey indicating that for every $10 rebate offered to the buyers, so we're dropping the price, the number of sets sold will increase by 200 a week. We drop the price and we sell more. We're trying to find the demand function and the revenue function. Okay, so what's happening here is that we're starting at 200 and we are going to increase the number that we sell. We're hoping to increase it by 20 per week every time we drop this price $10. We're currently selling it at $350. We're going to drop the price in $10 increments. Okay, we're going to use this dummy variable. Let D equal the number of $10 unit changes. In price. X is going to equal the number of CDs sold. And then P of X is the selling price, little p of X. So my revenue function, R of X, is X times P of X. And I'm trying to find the demand function. When it's asking you for that, it means find P of X. The revenue function is going to take X and multiply it by the demand function. Okay, X is the number of CDs sold. How many CDs are we selling? The number of CDs sold is currently 200, and we're going to get 20 more every time we give a rebate of $10. And what's my price I'm going to charge? The price is currently $350, and I'm going to drop it $10, and I need to, for every rebate offered. Okay, so then we are trying to come up with a price function. So we're going to, and we want this price function to be expressed in the variable X. Right now, it's expressed in the variable D. So we're going to take this piece of information, solve for D, and substitute into here. That is, X minus 200 is equal to 20D. Divide both sides by 20, and we get D. Put that into there. So here's my price function. 350 minus 10 times bracket X minus 200 over 20. Simplifying this, 350 minus 1/2 X minus 200. That is, I pulled the 20 out in front, which gives me 350 minus 1/2 X plus 100. What's my price function? P of X, just simplifying this, 450 minus 1/2 X. What's my revenue function? R of X is X times P of X. That is 450X minus 1/2 X squared. Okay, second part. How large a rebate should the store offer to maximize its revenue? So we're going to maximize the revenue and then answer the question, how large of a rebate? So how do we maximize revenue? Well, we want R prime, it's a parabola, to equal 0. That is, it's a parabola and it opens down. Where am I going to find its maximum? At the vertex. What happens at the vertex? The derivative is 0. Okay, so what's r prime? R prime is 450 minus x, the derivative of this function. That is, r prime equals 0 if x is equal to 450. Have I answered any of the questions? Just step 1 to answering the question. What did I find? X. What's X? The number of CDs sold. What am I trying to do? Maximize the revenue. How large a rebate should it offer? How am I going to find that out? Well, my current price minus my new price is going to equal the amount of the rebate that I offer. What's my current price? $350. What's my new price? So how am I going to find my new price? I'm going to put this into my price function. So what is the price at 450? It is 450 minus 1/2 of x. That is 225. So my original price, 350, minus my new price, 225, gives me the rebate, $125. How large a rebate should it offer in order to maximize revenue? The rebate should be $125. We didn't have to go back here and see what our D value was. It's kind of irrelevant. I guess 12.5 changes it, $10 changes in the unit price. What might be relevant is to answer a few other questions. What is the maximum revenue? You could just take the price that you're charging times the number sold. That'll give you your maximum revenue. But there's other ways to find it. You could also take your X and put it into your revenue function, find your maximum revenue. Okay, a couple of different ways to do it. Okay, so I'm going to give you a few minutes to work through the rest of those problems, especially the ones towards the end that involve that kind of a setup.